We take the natural log function over the interval from 1 to 2, so the natural log function would look like about like this from 1 to 2. It crosses the x-axis at 1, and it slowly arcs up. So now take this, that's this arc right here, and then rotate that about the y-axis. So this little piece that's at this angle is rotated around the y-axis, and then we need to find out if we were going to make that out of metal or coat the outside of it out of metal, how much metal would it take? Find the surface area. So for rotating about the y-axis, basically the theory is the radius, since we're going around the y-axis, the radius has to be measured from here to that arc. So consequently, the radius is not going up to the function, it's going across to the function. So that means that the radius is equal to x. So we'll have integrate from 1 to 2, 2 pi times the radius, which in this case is going to be our x, and then times the arc length. So that's the general idea. So for the arc length, we're going to need to know the derivative, and the derivative of natural log of x is a 1 over x. And then for arc length, we need the square root of 1 plus the derivative squared. So finally, we have integrate from 1 to 2 of 2 pi times x, and then arc length. So the square root of 1 plus this squared. Okay, now we need to integrate that. So the 2 pi could be factored out. That's no big deal. But what do we do with all of this? If you let 1 over x equal u, the derivative of that is negative 1 over x squared dx. So this dx would have to have a negative, or at least a 1 over x squared attached to it. It doesn't. U substitution isn't going to work. Trig substitution would be a good idea if this just said 1 plus x squared, but we would need to get rid of the fraction. Well, we're going to do that by saying this is really x squared over x squared, and combine these two. So if this 1 is replaced with x squared over x squared, I can then add the two fractions together. So I would have one big fraction, its denominator is x squared, and then this would say x squared plus 1 squared, or x squared plus 1. And then we could take the square root of this x squared, it would put an x in the denominator, which would actually cancel this x. So now we've got 2 pi factored out, integrate from 1 to 2, and then all that's left is the square root of x squared plus 1. And with this, square root of x squared plus 1, if you look back at number 21, here's number 24, if you look back at number 21, I did this problem, and that in itself took me about 11 minutes, I believe. It's pretty challenging. It turns out to look something like this. So if you want to see how to integrate this, look back at number 21. There's the lovely work. Instead of redoing the same thing, what I'm going to do is I'm going to go ahead and use the calculator to estimate this integral so that we do have a numerical answer. Let's see, so I need to integrate this thing. Oh, we've got a glare. So we need to integrate it. So the 2 pi and then the square root of 1 plus x squared. And then for the window, x should include the 1 to 2. And then it goes up to the teens, so I put 20. And if you look at the graph and then calculate the integral, number 7, from 1 to 2, it turns out to be an 11.373.